Hello and welcome to another section in further mathematics. In this section we'll be looking at a trigonometric integration. Trigonometric integration. That is integration of trigonometric functions. In our previous lesson we did something about differentiation of a trigonometric function. Today we'll be considering integration of trigonometric function. But before we continue, I would like us to take a quick review of our previous lesson, to take it as a guide into what we are about doing right now. Thank you. Okay, welcome back. Now when you talk about trigonometric functions, let's call this our fx. That's going to be integrated, and this is our integral of f of x dx. If you integrate sine x, you have minus cos x plus c. So if you have sine x, if you integrate sine x, this is called a trigonometric constant. Integration of sine x gives us minus cos x plus c. And if you integrate cos x, you now have sine x plus c. The integral of sec square x will give us tan x plus c. And the integral of cosec square x will give us minus the cot x plus c. The integral of sec x tan x will give us sec x plus c. The integral of e raised to power x, remember even in differentiation it doesn't change, plus c. And finally 1 over s, integral is ln x. Now one thing I want you to note is that, because you remember that in differentiation, when you differentiate minus cos x, you get sine x. So that's to say, if you integrate sine x, you get minus cos x. Now if you differentiate sine x, we usually have cos x. So that is to tell you that if you differentiate cos x, we have sine x. If we differentiate tan x, our value is usually sec square x. So if you now integrate sec square x, you have tan x. And the same thing applies down here. And we usually make use of it when each time we are solving a trigonometric integral. For example, let's integrate example 1. Integrate sine x minus 5 cos x. Now when you have something like this, you are expected to integrate sine x minus 5 cos x. Now what you are expected to do is, what is the integral of sine x? You come here, sine x is equal to what? Minus cos x. You write it minus, that's the integral. So it becomes minus cos x. Leave the plus c first, you add it at last because 1 plus c appears once. Then what is the integral of cos x? The integral of cos x. Cos x gives you sine x. So you now have the minus sign is still here, minus the 5 is here, 5 sine x, then plus our c constant. So this is equivalent to minus, you now have cos x plus sine x minus c. So this is the integral of this. Now I can also give you question number 2. Integrate 5 sine x plus 3x squared. Remember, during integration, our constant for integration is usually, let's note it down here, x n plus 1 over n plus 1. So we are solving this. I stated this because of the value of the 3x squared that just appeared here now. When you integrate, the integral of 5 sine x plus 3x squared will now be equals. Now let's do, we have our 5 that remains unchanged. Sine x, if you differentiate sine x, what will you have? Minus cos x. You now have your minus cos x plus, now let's apply this rule. The value of our n here is what? 2, because it's at the top of x. So it's now 3x 2 plus 1 3 all over 2 plus 1 3. Now our answer becomes minus cos times this is minus 5 cos x. 3 cancels 3 plus x 3. So the integral of this, the integral of 5 sine x plus 3x squared is equals minus cos x plus x cubed. You can still write it as x cubed minus 5 cos x. So this is the integral. That's how to apply the trigonometric functions when it comes to integration. Now I would like us to further into integration by algebraic substitution. Integration by algebraic substitution. Integration by algebraic substitution is one factor I would like us to clearly look into. Now, when you talk about integrating a function by algebraic substitution, it has to do with integrating it by adding an external constant when you're doing the integration, just like what we did when we're doing differentiation of quotient rule and that of product rule. So for example, let's do example number 1. Let's apply it here. If you're asked to integrate 2x squared minus 5x all raised to the power 4. Now what will you do at this point? The first thing you have to do is, you know, this is your y is equal to 2x squared minus 5x raised to the power 4. So at this point, the integral, you convert 2x squared minus 5x into u. You now say, just like what we did there, let u be equal to 2x squared minus 5x. And if u is equal to 2x squared, so you now have your du. Remember, in integral is the x. There's usually the x there. Du dx is equal to normal differentiation. Now differentiation is x n minus 1 with our n here. So okay, let me eliminate this for clarification. Have our x and our n here. So this just point of reference. So we now have 4x minus 5. So our du now, our dx is equal to du over 4x minus 5. You know what I did? I just cross multiply. So you now have dx to be equal to du over this. Now let's come back to this. We now had our equation will become y equals u raised to power 4 the integral dx. This is what this equation, because we just converted here, we say let u be equal to this. But you can't be integrating u and you're having dx, so we have to add the value of du here, of the x, remove the x, but this is a new value of the x. The x is equal to du over 4x minus 5. So this equation will become equal to integral of u raised to power 4, then times, in place of the x you put du over 4x minus 5. Then after this, now this serves as a constant. This is the same thing as y equal to 1 over 4x minus 5 integral u4 du. Now you no longer 4x minus 5 becomes a constant, because what you're having here is integral of du, and you have the du itself. So every other thing attached to it is a constant. You take it out. Now when you integrate du raised to power 4 using a formula for integration that states n x plus 1 over n plus 1. This is for integration. So if you apply it here, your equation becomes 1 over 4x minus 5. Then in place of this, you now have u raised to power 5 all over 5. And when you multiply this, is now 1 over 5 in bracket 4x minus 5. Then at the top you have u raised to power 5, which is still equal to u raised to power 5 all over 20x minus 25. But the value of our u originally was 2x squared minus 5x. So the integral becomes, the final answer becomes 2x squared minus 5, that is u raised to power 5, divided by 20x minus 25. Now this is called integration by algebraic substitution. So you integrate it raised to with an external constraint, and after that you convert it back to your final answer. I'll say a very big thank you for joining us in this lesson. But in order to refresh your memory on what we've just discussed, please, it is advisable you take the test that will appear shortly on your screen. Do well to use this lesson notes on the platform for better information on the topic we've just discussed. Thank you, and see you in our next lesson.